Welcome back. This is going to be the last lecture for this semester. As far as this course is concerned, we will have some tutorial questions that I can share. So that will be just help you in preparation. Otherwise, all lectures will be completed today with this one, with this last video. Okay, so in last video lecture we derived n1, n2, n3, n4. These are shape functions, and also derived the stiffness, the first component of the stiffness matrix, that is K11, and we got this to be 12 EI over LQ. Okay, so let's look at K12 component. Okay, so as I said earlier, that you can just use this equation Kij 0 to L, then d square ni dx square ei d square nj dx square dx. If you just use this equation and given all the equations, the shape functions here, and you can integrate it, you can find out. Okay, so that could be found out very easily. However, what I'm going to tell you that you don't have to evaluate or find all of them. Okay, so few things will be known automatically, and that's what I'm going to show. Okay, so that you don't actually like integrate many times, okay, to get that. So for example, if you have K11, so that really means that if you have applied K11 as I suggested earlier, like when we were studying the chapter 2, then the direct stiffness method. So K11 is nothing but, that really means is you are applying a displacement at node 1. How much displacement? Displacement is u1 equal to 1. Yeah, this is displacement, and all other place you are fixing it. So that means theta is also, theta 1 is equal to 0, then u2 equal to 0, and theta 2 is also equal to 0, and only u1 equal to 1. In order to get these displacements, whatever force you need will be the stiffness components. Okay, so the force what you need to make u1 equal to 1, theta 1 equal to 0, u2 equal to 0, theta 2 equal to 0 will be known as K11, and this alone will not be able to do, so there will be other forces as well. So this will be K12. Okay, so this is going to be K13, and similarly the moment required here will be K14. So these are the real forces have to be applied simultaneously in order to get u1 equal to 0, theta 1 equal to 0, theta 2 equal to 0, and u2 equal to 0. This is the definition of K11. Okay, so this is I'm just repeating from what we studied in chapter 2, so direct stiffness method. Okay, so that really means, if you look at it, that really means the in order to see the balance, so for the force balance, for all the forces here are K11, K12, K13, K14. So if you see the vertical forces, all vertical forces has to be equal to 0, and what we get is K11 plus K13, this and this, they should sum up to 0. Hence K13 we get equal to minus K11 is equal to minus 12 EI over L cube. So we get this automatically. So we did not need to actually find out K13. So we get that. Okay. And next is if K11 we know, K13 we know. Now only one equation we have now, balance equation, that is the moment equation. Okay, total moment has to be equal to 0. However, we have two variables K12 or K14. So one of these, one of K12 and K14 we have to find out. So let's find out K12. Okay, so K12 will be equal to 0 to L, then d square n1 dx square ei d square n2 dx square dx. Okay. So equal to ei, so 0 to L. Okay, so we can also find write down here the dn d square n1 dx square will be equal to, so here we are going to integrate this twice, so this becomes 6 minus 6 over L square, and this becomes 3, then 2, 6 times 2, 12 plus 12 x over L cube. Similarly here d square n2 dx square, that becomes equal to, so this will be gone, this will have 4 over L. Okay, so 4 over L minus this again 3 times 2, 6x, so minus 6x over L square. Okay, so here d square n1 dx1 is minus 6 over L square plus 12x over L cube, then ei, then we have 4 over L minus 6x over L square dx. Okay, so if you integrate it, here ei is constant, and then you multiply this with this and integrate it, the value you should get is 6 ei over L square. Okay, so once we have K12 and K11, okay, then we can have the moment equation to find out K14. Okay, so we can draw the diagram again. So you have a beam here, and then you have K11 is equal to 12 ei over L cube. Okay, and then you have a moment is anticlockwise because we got the positive value, and the value of that moment, that is K12, is equal to, so this is K11, this is K12, which is equal to 6 ei over L square, and this also, here we know the value we get negative, so this K, we just write it here, the value which is negative, so we have drawn it downward, and this is minus 12 ei over L cube. Okay, so since this is we have already given the sign downward, so we don't write minus here, so sign is negative, magnitude is 12 ei over L cube, and what we have to find out, we have to find out this one, and this value is again anticlockwise, and this value is K14, and this we have to find out, and this is a moment. Yeah, so distance from here to here is L, so we can find out K. If you take the moment about 0.2, so moment about 0.2 has to be equal to 0, and hence what do we get? We get anti-clockwise this one, so we write 6 EI over L square. Then clockwise is this due to this one, so 12 EI over L cube times L is this will be negative because this is clockwise, so anti-clockwise is clockwise, this is also anti-clockwise, so K14, okay, and this will not participate because lever is 0, so all should equal to 0. Okay, so what we get? We get K12 equal to 12 EI L square minus 6 EI over L square equal to 6 EI L square. So we get already K11 is equal to 12 over 12 EI, we got L square equal to minus K13. So we got these values already, and K12 we got, and K12 we have, sorry, this is K14. Okay, so so K12 is equal to 6 EI over L square, and K14 is also equal to 6 EI over L square. So we get the first row completed. Okay, so first row will be 12 EI over L square, 6 EI L square, then minus 12 EI over L square, then 6 EI over L square. Once we know that, then we can compose basically. So we say K equal to, we can put those values. The first will be 12 EI. So let's write EI outside, EI over L cube. Let's write outside. So what we get here is, first one becomes 12 EI L cube. Okay, second term is this. So second term will be 6L. So that you multiply with this, you get 6 EI over L square. Third term is 12, and fourth term is again 6L. So we get this term. Now remember, this has to be symmetric. Okay, so we will come to know many of them automatically. So we have 6L here, so there will be 6L again here, this is minus 12, then here also we will have 6L. So because they are symmetric. Okay, so the column, this row and column will match, and hence we have like this one. Okay, always this and this should add up to 0. So if you know 6L here, this will automatically be minus 6L here. Okay, in all cases these and these are related to the vertical forces. Okay, so they should add up. So this minus 6 minus 12, so we get 12 here, and 6L we get minus 6L. So we got this already. Okay, now also we have to see the symmetric, because this one is, if it is 1, 3 is minus 6, so 3, so no, sorry, 2, 3, 2, 3, K23 is this, so K32 should also be this one. So here, so this also should be minus 6L. Okay, okay, so this is minus 6L. Similarly, we have to see others as well, so we have to find out this one. Okay, we will look at that later on. Again, this is this one we have 3 3, and this if this is minus 6L here, so we get minus 6L here as well, so minus 6L here. So we get like this one, this, this. So what we have is row number 1 and 3 complete. What we don't have here is this and this we don't have, this and this we don't have. Okay, so we have to find out what next. We can find out K2 K22. Okay, we have to find K22. If we know K22, then this we can find out this one, and accordingly this also. So let's find out K22. So K22 is equal to 0 to L EI. Let's keep this outside, and then d n2 over d square n2 d x square of it and dx. So EI 0 to L, and we have here d square n2 dx square, so 4 over L minus, so 4 over L minus 6x over L square, so a square of it and dx. Okay, so what do we get? We get here EI multiplied by 4 over L minus 6x L square, and then cube 1 over 3, and then 6 over L square. Okay, and from L to 0, hence we get EI, and here we put L here, so we get let's take this outside, so we get L square over 18, so L square over 18 here, and then this we put L here, so we get 4L minus 6 over L. Okay, so becomes minus 2L. Okay, so put L here, so 4L minus 6 over L, so you get minus 2L, and then minus okay, this will be the cube of it, and then minus, and this is 4 over L and cube of that. Okay, so finally what do we get? We get let's keep EI L square, then 2 to power 3 18 multiplied by, and here we have minus 1 over L cube, and here 8, 2 times 2 times 2, 8 over L cube, so here minus 1 over L cube, here minus it, so minus 9 over L cube, so minus 9 over L cube. Okay, so the value that we get will be, so 9 becomes 2 here, becomes 4 here, so 4 EI over L, so 4 EI over L, plus or minus, it will be minus like this. Okay, so something is wrong though, because this K22 is a diagonal term, it cannot be negative. So yeah, so here we have to divide by minus 6 over L square. Okay, so here it should have been minus here. Okay, so minus, so hence if you bring it here, minus you get here, and hence you get minus and minus plus. Okay, so this should be plus. Okay, so we get plus 4e I over L. Okay, so now it's correct. So remember, always the diagonal term always be positive. Okay, should not be negative. So we have to get k22 equal to 4 ei over L. So ei, so we write 4 here, then L square. Okay, for L square, because then you multiply with this and you get 4 ei over L. So we get this one. Okay, now the if k22 is 4 L square, means 4 ei over L, what will be the value of this one? So for that we can see we have to see the moment equation, accordingly do it. However, that we will do on the next page, but here if we have this value here, we can find out here based on the moment balance, and same value we will put it here, and here we will see what should be the value. Okay, just remember that we are going to work on this one. We have to find out this one, and so this is the vertical force. Okay, so this will be 6 ei over L square, then we have a moment 4 ei over L, then again on the second end we have minus 6 ei over L square, and then this we have to find out. So we will draw that, okay, with these forces and moments. So let's draw the beam here, and for the second row we have force here, this one, so this is 6 ei over L square, so this is 6 ei over L square, then there is a moment which is 4 ei over L, okay, and this is this force 6 ei over L square, since this upward has to this value is negative there. Okay, so and this we have to find out. Okay, and this will be k24. Okay, so equal to what? So we sum the moment about 0.2, this is 0.1, 0.2 or not 2, and has to be 0. So what we get? This anti-clockwise, so we get 4 ei over L, and this is clockwise, so minus 6 ei L square times L, distance from here to here is L. Okay, and then this is also anti-clockwise, so k24 equal to 0. So what we get? We get k24 equal to 6 ei over L minus 4 ei over L, and hence you get 2 ei over L. Okay, so let's go back to the k expression. What we get here? We get 2 ei over L, so we write 2 L square here, and since this is symmetric, so same value we will put it here. So k24 equal to k42, so this is k42 is 2L square. Okay, now we have to find out k44. Okay, so k44, remember that the meaning of, let's understand the meaning of k44. So here so you are trying to, the k22, for example, what is k22? K22 is you are applying a moment to induce theta 1 equal to unity, and whatever the moment is, that is the K22. So basically K44, and what is the K44? K4 will be the same thing. Here you are fixing this end, and here you are going to apply a moment K44 to induce theta 2 equal to 1. So if you see, if K22 is a moment to have a slope theta 1 equal to 1 here, and if you see, these and these are just the mirror image, so whatever moment required here will be required here, hence K44 equal to K22. So this again we have done in chapter 2, direct stiffness method. So we can copy here basically. So whatever you get K22 value will be the same here for K44. So you can do like that. Okay. Otherwise you can also based on equation also you can do it. If you see n2x like this one, so n4, if you take n square n4 over the d square n4 over dx square, what do you get? You get minus 2 over L plus 6x over L square. Okay. Otherwise you can just use n4, this d square n4 over dx square to a square of that if you integrate, and then you will get the value for K44. Thus we have seen that we evaluated just 3 of the components. We evaluated K11, K12, then K22, that is all, and the rest of them were evaluated just by using the force balance equations only. Yeah, so that is actually, that makes it faster actually. Otherwise you can, as I said earlier, we can actually use the equation for Kij. This is the equation, we can always use that. Okay. Now all the integration we actually use the analytical equation only, not numerical equation, numerical integration. So for all integration we use the analytical integrations. In order to be able to implement the numerical integration, we have to again convert all these from 0 to L, x equal to 0 to L, to the system of xi from -1 to 1. Yeah. So either you can change the coordinates here as we have done in the previously, okay, or you can have the isoparametric element for beam. Okay, so that will automatically have the integration for domain of xi from -1 to 1. So no need to actually change it, and that makes also life easier because you can easily write the shape function. So let's do that. Okay. So what I mean to say is you have a beam which is from L here. So this is from 0 to L, and this is x moving like this. So we are going to transform it such that you have, this is x goes like this. Now we have xi equal to -1 here and xi equal to 1 here. Here we had x equal to 0 and here x equal to L. So this transformation that we want, okay. And if you remember the transformation that we used, we said x xi equal to, sorry, x equal to, so we have 0 plus L over 2 plus L minus 0 over 2 times xi. Okay, so or x equal to, in this case, L over 2 plus L over 2 xi. So if xi equal to -1, you have x equal to 0, right here. If xi equal to 1, you have x equal to L. So this is the transformation we used. Okay. Okay. So now this is the we still have the same kij. If you have to find out, we have 0 to L d square ni dx square ei d square nj over dx square dx. Okay. Then we can convert this into that. Okay. So how to convert? Let us say this is dx. So from here we know that this has tell us that dx equal to L over 2 d xi. So we can write like that. We can also express ni in terms of xi. So from these two we have to convert into ni as a function of xi. Okay, or we can write ni in terms of xi directly. Okay, so let us say if you write ni in terms of xi only. Okay, so what we want, this is xi equal to -1, xi equal to +1. This is the same way what we have been doing for isoparametric element. And we have n, first one, let us say n1 you want to write in terms of n xi, and how it will be. Remember, we wanted the slope ni, the slope of it should be 0 here also, and ni has to be 0 here also. So basically, what will be the quality of n1 I would say equal to 0 at node 2. Okay, that is xi equal to 1. Okay, and dn1 over d xi, dn1 over d xi equal to 0 at node 1 and 2 both. Okay, we want slope to be 0 at both places and the value has to be 0 like this. So this is the definition we have seen when n1 is a function of x also. We wanted n1 to be 0 for the slopes at these two nodes, and also the value has to be, n1 has to be 0 at node 2. So similar to this only. So if you want to satisfy like this one, let us say if we had just node 2, you had to make equal to 0. So then we looked at the equation, and this 1 minus xi term has to be there. So n1 xi equal to, if we had to just look at xi and say when n1 has to equal to 0 at xi equal to 1, we would have just written 1 minus xi, that's it, right? However, we want n1 to be 0 at node 2 and also the slope of n1 to be 0 at node 2. That really means when is it possible? When is possible that the value is 0 and its derivative is also 0. That's only when you have a square basically. So if you square of 1 minus xi, that really means if you differentiate you get 2 times 1 minus xi, you put xi equal to 1, this becomes 0. So slope is 0 and value itself is also 0, both are 0. So that's why 1 minus xi square. Okay. Here now what is remaining here is slope of this one at node 1 also has to be 0. So what will be the value? That we have to find out. Okay. So we can just say, okay, let's have one guess and we can say that n1 equal to one constant alpha, let us say alpha plus xi. Okay. Alpha plus xi, if we multiply with 1 minus xi square, will make n1, slope of n1 equal to 0 here. Okay. So let's take a derivative dn1 d xi. So what we get? Differentiate here this one, we simply get 1 minus xi square, and then we get plus alpha plus xi, and then we get 1 minus here we get 2 1 minus xi. Okay. Now put xi dn1 d xi at xi equal to minus 1 has to be equal to 0, and what we get, sorry, has to be a square. So we get 2 square plus alpha plus xi, and here you get 2 times 2, this all equal to 0. So we get the value of alpha from here. So that really means alpha equal to 4, becomes minus 4 here, minus 4 divided by this 4 also, this one is minus 1, sorry, this becomes minus 1. Okay. So minus 4 divided by 4 plus 1. Okay. So alpha equal to 0. No, something is wrong. Just hold on. Yes, there is a mistake here. So if you differentiate this one, it should be 2 times 1 minus xi, and then we will also have minus 1 here. So differentiation of this will be minus 1. So we have minus 1 here, multiply by minus 1. Okay. So that makes it this one is minus equal actually. Okay. Hence we get alpha alpha equal to let's write it again. So what do we get? We get alpha minus 1 equal to 4 by 4 equal to 1, and hence we get alpha equal to 2. Okay. Hence we put that value here, and we get n1 xi equal to 2 plus xi, then 1 minus xi square. Now remember n1 also has to be equal to 1 at xi equal to minus 1. So, put that value. Okay. So, what do we get? n1 minus 1 in this case becomes 2 minus 1 1, and here 2 square. So, what we get? Total 4. So, this is not equal to 1, right? It is not equal to 1. Hence, we will put n1 xi equal to 1 over 4 2 plus xi 1 minus xi square. So, this is the final form of the n1. Okay. This is how you can compose n1, n2 and so on, n3 and 4. n1, n2 is easier. So, n2 xi. So, n2 is the one which is equal to 0 at 1, 0 at 2, and slope of that at node 2 will be 0. So, 0 here, here, and slope 0 here. So, here both 0, so we have xi plus 1 and xi minus 1, both terms will be there. So, let us put here. To begin with, we can write like this. So, first we look at n2 should have 0 here, and slope of that also should be 0 here. So, 1 minus xi square will be for sure, and then it has to be 0 at xi equal to minus 1. So, it should also have xi plus 1 plus xi term. So, 1 minus xi square times 1 plus xi. So, we will simply have, let us call it, there is a constant C2 times 1 plus xi multiplied by 1 minus xi square. This will make sure that n2 is 0 at xi equal to minus 1, and it will make sure that n2 equal to 0 at xi equal to 1, which is required, and slope of this is also 0 at xi equal to 1 because of the square term. So, n2 is done. What we want? We want n2 at xi equal to So, this automatically is 0, only we have to check what is the slope, value of slope. So, dn2 d xi equal to, we get C2 1 minus xi square plus C2 1 plus xi and 2 multiplied by 2 1 minus xi and minus 1. So, here it will be minus 1. So, put dn2 d xi2 at xi equal to minus 1 has to be equal to 1. So, equal to C2 1 minus 1, the 2 square minus C2, here you have 1 because minus 1 term here. So, this becomes 0 simply. Xi equal to minus 1 you put here. So, everything becomes 0. So, all equal to 0. So, that really means C2 equal to 1 over 4. Okay. So, simply we will have n2 xi is equal to 1 over 4, then 1 plus xi and 1 minus xi square. So, we got n2 this way. Similarly we can also find N3. Okay, so N3 xi equal to what? For N3 is here, right? So we want value has to be N3 is 0 at xi 1 at xi equal to minus 1. Okay, and dn3 d xi will be 0 at xi equal to plus minus 1. Sorry, so N3 has to be 0 here, both of them, N3 relates to the vertical degree of freedom. Okay, the vertical degree of freedom. Hence, only N3 at xi equal to plus 1 has to be non-zero, otherwise all will be 0. So, N3 equal to 0 here, N3 over d xi is 0 at xi equal to plus minus 1, that's correct. Yeah. Okay. So, then how to compose? We can compose N3 xi is equal to, let's say we call it C3, and then what should we have? We should have at xi equal to minus 1 or 1 plus xi we have to square, so that N3 is 0 at xi equal to minus 1 and derivative of N3 is also 0 at xi equal to minus 1. Okay. Additionally, it should also be, the slope should also be 0 at xi equal to plus 1. So, let us call this one is equal to some value beta plus xi. Okay. Again, this has to be cubic, so this is what we can write. So, we have to find out value of C3 and beta. Let us find out value of B3 first. So, dn3, this will already make sure that N3 is 0 at xi equal to minus 1 and slope of N3 also 0 at xi equal to minus 1, but we have to test now, slope should be 0 at xi equal to plus 1. So, xi3 xi equal to plus 1 equal to C3 1 plus 1 square beta plus 1 has to be equal to 0, and that really means, we have to take slope first. Okay, so dn3 d xi is equal to C3 then 2 1 plus xi beta plus xi plus 1 plus xi square this. Okay, so this has to be 0 dn3 d xi at xi equal to minus 1 has to be equal to 0. Sorry, xi equal to plus 1 has to equal to 0. So, that really means what? That means C3 2, then 2 here, beta plus 1 here, plus 2 square will be equal to 0, or we get beta plus 1 equal to minus 4 by 4 equal to minus 1 and beta equal to minus 2. Okay. Hence, Hence n3 xi becomes equal to C3 1 plus xi square, then minus 2 plus xi. Okay. Now we have to find out value of C3. We have to know that N3 at plus 1 has to be equal to 1. So C3, and then we have 2 to the power 2, and here the value is 1, so this becomes minus 1. Okay, so that makes it C3 equal to minus 1 over 4, or simply n3 xi is equal to minus 1 over 4, then 1 plus xi square, and then minus 2 plus xi. Okay, so this is what the n3 is. Now n4 you can find out accordingly. So n4 equal to what? So n4 should be such that this is 1 2 xi equal to minus 1, xi equal to plus 1, and has to be n4 0 at xi equal to plus minus, okay, plus minus 1, and dn4 d xi is also 0 at xi equal to minus 1. So that means it has a repeated solution at xi equal to minus 1, and that really means we should have n4 xi equal to say C4, then xi plus 1 square, and then 1 minus xi term should also be there. This is how it should be. Okay. Now if we the value of n4 rather the value of slope of n4, so dn4 over d xi equal to C4 2 xi plus 1 minus xi plus xi plus 1 square minus 1. Okay, this has to be dn4 xi at xi equal to plus 1 has to be equal to 1. Okay, and that really means C4, and you have 2 plus 2, then 1 minus 1, so this becomes 0, plus 2 square minus 1 is equal to 1, and that makes it C4 equal to minus 1 over 4, and hence n4 xi equal to minus 1 over 4 xi plus 1 square 1 minus xi. Okay. So we got all n1, n2, n3, n4 in terms of xi, and what we have is k ij equal to 0 to L d square ni over d x square ei d square nj over dx square dx. Now we can write in terms of xi only. Okay, so that's we will do now. So I wrote the same thing here, expression for the kij, and also we know the transformation between x and j, and transformation was x equal to L over 2 plus L over 2 xi, and that makes is dx equal to L over 2 d xi. Okay, so we can put those values here. Now what we have is ni in terms of xi, so d ni over dx becomes dni over d xi, then d xi over dx. So this tells us d xi over dx equal to 2 over L. Okay, so d xi over dx equal to 2 over L. So this is equal to dni over d xi and 2 over L. So we write here 2 over d xi over dx, d xi over dx, 2 over L dni over d xi. Okay. Similarly, d square ni over dx square equal to now d over dx, 2 over L dni over d xi. That makes it 2 over L d square ni over over d xi square, then d xi over dx, which is equal to, we will have 2 over L square of that and d square ni over d xi square. Okay. So we have this expression, hence kij you can write now, kij equal to, now where x is 0 we have xi equal to minus 1, where we have L xi equal to plus 1, then d square ni over this, so this becomes 2 over L square d square ni d xi square ei. Okay, same term will be for here, so 2 over L square d square nj d xi square, and then dx equal to L over 2 d xi, so L over 2 d xi. Okay, so this is kij in terms of xi actually. So minus 1 to 1, and then we just write here d square ni over d xi square ei, d square nj over d xi square, okay, d xi, and then we have take this outside, so you get L over 2, 2 over L, 2 over L, so we have 2 over L power cube, right? So what we get finally? Finally we'll get k finite form k I is equal to 2 over L cube of that, and then 0 minus 1 to 1 d square ni over d xi square ei d square nj over d xi square and d xi. So you can also calculate kij like this one. Here you have xi in terms of xi, and xi values from minus 1 to 1. So you can apply the Gaussian quadrature formula here to integrate, and this is how it is done in computers. Okay. So although we use different method to find out the stiffness matrix, the value should be the same. So whatever we whatever matrix we got earlier, we will get the same matrix using this formula also. Okay, it is just an alternative method. However, this helps you in doing the Gaussian integration method. Numerical integration you can do using the Gaussian quadrature formula. Okay, so that is all as far as the lectures for ME515 is concerned. So later on I will send you some problems, and I will ask you to solve it, and then later I will send you solution, and you can check whether your solutions are correct or not. Okay, so that's what we will do next week. But as far as the lecture is concerned, we are closing it here right now. Okay, thank you very much. Okay, see you later.